Tonight, the sky above you holds roughly 200 billion suns. Most are too faint for your eyes. Most live in neighborhoods your fastest rocket could never reach. But they are there, burning, all of them, at this exact quiet second. The universe is almost 14 billion years old. That is a number your mind will round off into a feeling, because no brain alive can hold it as a real count. 13.8 billion years of silence and motion and slow expansion. 13.8 billion years of gravity patiently arranging dust. And in that long unfolding, something strange is happening right now. Something we almost never stop to notice. We happen to be alive during the luminous part.
Imagine the full life of the cosmos stretched across a single dark corridor. Walk it end to end, and the corridor would not be 14 billion steps long. It would be so much longer than that. The corridor does not end at today. It reaches outward into deep time that makes today look like the opening syllable of a sentence, 100 trillion words deep. And the stars. The stars are only lit inside a tiny slice of that corridor, a hairline crack of light near the very beginning.
If the whole lifespan of the cosmos were pressed into a single year, every star that ever shone, every sunrise on every planet, every candle of starlight, drifting through every telescope of every civilization yet to come, would all fit inside the first morning of the first day of January. 1 in a million. That is the ratio, roughly, of the starlit era to the darkness that comes after. 1 part in a million. We are the rare eyes opened during the flash. If you could rise above the night, above the thin skin of the atmosphere, above the moon, above the slow spinning disk of our galaxy, and look down from outside, you would see something that will not always exist. You would see pinpoints, ribbons, whirls, clusters.
You would see the Milky Way as a single soft ember in a vast black room, one of perhaps 2 trillion galaxies, each one a cathedral of burning things, all of it alight. Listen, there is no sound in that view. Space does not carry sound the way air does. No sigh, no crackle, no hiss of a star breathing. And yet, if you could translate the physics into a hush you could hear, the whole sky would be murmuring. Every star is a slow, steady exhale of light and heat, a furnace older than anything you have ever touched. Consider the scale of a single furnace. Our sun weighs as much as roughly 330,000 Earths piled together.
Its core is squeezed to densities your imagination cannot honestly picture. Inside that core, every single second, 600 million tons of hydrogen fuse into helium. Every second. Think of the weight of a mountain, crushed and converted into light, and then another mountain behind it, and another, for billions upon billions of years, without pause. A star is not a thing. A star is a patience. A star is a long-held breath. And yet, even that patience runs out. Here is the strange truth you are being handed tonight. The universe is not built to stay bright. Starlight is a phase, not a setting. Stars are not eternal residents of the sky. They are guests. They arrive, they burn, they leave.
Some of them last a few million years. Some last billions. A rare, small, frugal sort of star can last trillions, but nothing burns forever. Not one of them. Not even in principle. And because the universe keeps expanding, because new gas clouds are slowly being used up, because every generation of stars locks more matter into remnants that will never fuse again, the bright epoch of the cosmos is not just brief, it is also finite. There is a last star out there, somewhere ahead in a future so deep it blurs the meaning of the word future. There is one final stellar flame waiting to flicker out. And after that, nothing new will ever be born that shines. We do not know its name.
We may not yet know the galaxy that will hold it. We do not even know the kind of star it will be, though we can guess. But it exists in the same way a last heartbeat exists for every living thing. It is written into the shape of the laws we have been given. And this is the arc we will walk together tonight, slowly, quietly, through the long, gentle dying of the sky. We begin here, in the Age of Starlight, where you happen to live. In this age, the night is crowded. Look at any patch of dark sky through a powerful enough lens, and it fills with pinpoints, galaxies behind galaxies, a deep well of light.
In this age, new stars are still being born, slowly, in cold nurseries of gas and dust. In this age, planets form, oceans condense, continents rise, and sometimes, every so often, a thin film of life drapes itself across a single warm rock. In this age, creatures like you open their eyes at night and feel small. That feeling, small beneath a bright sky, is one of the oldest feelings a mind can have. But it is also a temporary one. The sky was not always this full, and it will not stay this full. To understand how rare this moment is, walk outward in your imagination. Leave the city. Leave the country.
Leave the sunlit side of the planet and stand on the dark side, with the horizon clean and empty. Look up. The light you are seeing did not happen now. Every star up there is a letter sent from a different past. Some letters are a few years old. Some are thousands. Some were written before humans existed. You are reading a mail carrier older than your species. And the postman, right now, is still delivering. For 100 billion more years, he will keep delivering, though more and more slowly, and to fewer and fewer addresses. After that, the routes begin to go dark, one by one. It is a gentle thing, this dimming. It is not a crash. It is not a violence.
It is a long, low evening that the cosmos is walking into at its own pace, with no audience, no witnesses, no one to mark the end of the lights, except us, perhaps, for a while. We are the strange side effect of an era of burning. We are eyes that woke up because the sky was bright enough to wake something. What does it mean to live inside the one bright moment a universe ever gets? That question has no practical answer. But tonight, we can let it sit at the edge of the mind, the way you might let an ember sit at the edge of a hearth. Warm, brief, worth looking at for a while.
Now, drift inward. Leave the distant sky behind. Travel across the cold black, across the orbit of every far wanderer, past ringed giants and frozen moons, until you come back to the familiar yellow star that warms the window you know. Our sun. Your sun. The one that has been quietly pouring light onto your ancestors since long before there were ancestors. A middle-aged star, roughly 4.5 billion years old, turning hydrogen into helium at a steady, almost boring rate. On a human calendar, it has done this without pause for 14 trillion days. And it will do this, more or less, for about 5 billion years more. 5 billion years. Try to hold that gently.
A single human lifetime, on average, measures to maybe 80 laps around this sun. The entire story of written language covers fewer than 10,000 laps. Every king, every empire, every song sung in every language that has ever existed rests inside the first blink of the first second of that number. 5 billion years is not a length of time. It is a landscape, a country. A slow, vast, unreachable country in which our sun still burns, calm and warm. But the country has an edge. Inside the sun, fuel is being spent. Every second, hydrogen at the core becomes helium. Every second, the core gets a little heavier, a little denser, a little more packed with the ashes of older burning.
For now, this slow accumulation is invisible from the outside. The sun looks the same in your sky today as it did in the sky over a trilobite. But far inside, the balance is shifting, 1 gram of helium at a time. Eventually, the core will run out of hydrogen to fuse. When that happens, the sun will begin to change. Not all at once. Not dramatically at first. It will begin to swell. Picture the sun slowly inflating, as if something inside were letting out a long, tired breath. First, it grows past its current size, brighter and brighter. Then it grows past twice its current size, then 10 times, then 100.
A red glow seeps into the color of the sunlight, deeper and deeper, until the sun looks nothing like the quiet yellow lamp it is today. It becomes a red giant, a vast, bloated, restless star with cooler skin, but unimaginably more light. If a human being stood, somehow, on a safe observation deck at the orbit of present-day Earth, and watched this transformation over hundreds of millions of years, they would see a slow engulfing. Mercury, innermost child of the sun, would be eaten. Venus, next in line, swallowed into the outer atmosphere of the dying giant, would vaporize.
Earth itself, our home, blue and brown and wrapped in clouds, would likely be pulled in and consumed, or, if spared by orbital drift, would be scorched clean, reduced to a ball of black, lifeless rock turning under a red sky. The oceans would not simply evaporate. They would not be given that kind of slow, gentle death. Long before the sun reached its final swollen size, the oceans would be boiled off entirely. The atmosphere would be stripped away into space, peeled off like paper from a lantern. The continents would glow. The land would soften and then liquefy. And then the engulfing would finish the story. Imagine standing on a shore, somewhere in an unfathomable future, watching your own sky fill edge to edge with red fire.
No ocean behind you, no forest, no city, just red, above and around, like being inside a furnace the size of a solar system. This is what the death of a home looks like, when the home is a planet. But even the red giant phase is not the end.
It is only the middle of the ending. A red giant is not stable. It pulses. It shudders. Layer after layer of its outer shell drifts away into space, blown gently by the wind of its own radiation. Over time, this outer material peels off, widening into a glowing halo called a planetary nebula. It is one of the most quietly beautiful things the universe ever makes.
A spiral, or a ring, or a dumbbell, or a butterfly of soft-colored gas, lit from within by the naked core of the star that made it. That naked core is what our sun will eventually become. A white dwarf, small as stars go, roughly the size of Earth, dense beyond any earthly experience, so dense that a single teaspoon of its matter would weigh as much as a small car on the ground. What remains of the sun will fit inside a volume smaller than some asteroids, yet still outweigh 100,000 Earths. This white dwarf will not fuse. It will not create new light. It will only glow, faintly, with the leftover heat of billions of years of burning. Slowly, it will cool.
For tens of billions, perhaps trillions of years, it will give off a soft white shine, then a pale yellow shine, then a dim orange, then a deep red, dimmer and dimmer still. Inside that white dwarf, the ordinary rules of matter have already given up. The electrons no longer orbit the nuclei the way they do in the air you are breathing right now. They are crushed together so tightly that they refuse each other, resisting further compression with a force that is not pressure in any familiar sense, but a pure, stubborn consequence of quantum law. The entire corpse of the sun will be held up, for eternity, by a rule written into the smallest particles, a stone supported by nothing but geometry.
A mountain leaning on a sentence from physics, and as it cools, it begins to crystallize. The carbon and oxygen inside arrange themselves over vast stretches of time into a single enormous lattice. Imagine that, softly, at the edge of sleep, the heart of our sun, after everything, becomes a diamond. Not a metaphorical diamond, an actual crystalline structure of carbon, denser than any jewel ever dug out of the earth, hundreds of thousands of kilometers across, humming quietly in the dark. The star that grew your bones, ending as a vast, slow gem.
If another consciousness, far in the future, lived near a world that survives somewhere in the ancient wreckage of our solar system, they would see in their sky a tiny, hot, lonely ember, no bigger than a bright star, where the sun used to be. And they would not know, perhaps, that this ember had once turned oceans into weather and grown forests and fed the soft thinking of a species that invented music. Eventually, even the ember will fail.
No black dwarf exists yet, anywhere in the universe. The cosmos is too young to have made one. The process takes so long that no star in history has had time to complete it. Our own sun, when its time comes, will still not be the first. We are talking about cooling ages that dwarf the current age of existence itself. A black dwarf is not a thing that has happened. It is only a thing that will. Think of that slowly, if you can.
The sun that has been warm for your entire species, whose light is folded into the chlorophyll of every leaf you have ever touched, whose rise and set once measured every day on every calendar you have ever known, will one day be colder than the space between galaxies. Dark, silent, a heavy stone in a black room. And still, in the long story of the stars, the death of a single yellow sun is only a footnote.
The heat death of a world like Earth is not a problem for any living memory, and yet knowing that it waits out there, already written into the physics of the sun over your head right now, gives the morning a weight it did not have before. The light that presses on your eyelids today is the same light that will, in time, burn the sky of a dying planet. The same hand, the same furnace. What is it like to be warmed by something that is already dying? You have always known the answer to that. You have always been warmed that way. Every fire you have ever felt has been a dying fire. Now, drift outward again. Leave this small yellow star behind. Travel across the galaxy, past stars older than ours, past stars younger, past stars so different from the sun that the word star barely holds them all. Because in the Age of Starlight, the sky is not uniform. It is a vast library of furnaces, and some are whispering, and some are screaming. The largest stars are the loudest. A single blue giant, one of the great hot hammers of the cosmos, can weigh 50 times, 80 times, sometimes more than 100 times as much as our sun. From a safe distance they look beautiful, sharp and violet-white, brighter than almost anything else in the sky. But their beauty is a warning. These stars burn so fiercely, so wastefully, that they eat through their fuel in a geological eye blink. Where our sun will live 10 billion years or so, a blue giant may live only a few million. They are the candles that chose to be explosions. And so, in the long scheme of things, they go first, always. Every day, somewhere in the observable universe, a massive star is ending. Not theoretically, actually. As you sit quietly with this narration in your ears, roughly once every second, a giant star somewhere collapses or detonates. The light of these events takes so long to reach us that we see only a thin sampling, 1 or 2 every 100 years per galaxy, but the tally, across 2 trillion galaxies, is relentless.
Giants are always falling, always, in all directions. Forever until there are no giants left. The death of a giant star is not a gentle dimming, the way our sun will one day dim. It is a catastrophe on a scale that breaks metaphor. When the core of a massive star finally runs out of fuels to fuse, when it has made iron and cannot burn iron for energy, the floor beneath the star collapses. In less than a single human second, a volume the size of a small planet falls inward to the size of a city, and then further, down into something even smaller. The outer layers, suddenly unsupported, follow the collapse, slam into the dense core, and rebound outward with so much force that the entire star is blown apart from the inside. This is a supernova. One dying giant briefly outshines an entire galaxy. A single point of light in a single sky flares up so violently that for days or weeks it competes with the combined glow of hundreds of billions of ordinary suns. Somewhere in the deep history of our own galaxy, such points have appeared again and again. In the year 1054, human beings on Earth watched one of them, a sudden new star in the constellation of Taurus, so bright it was visible in daytime for weeks. They did not know they were watching a funeral.
But they were. Every element heavier than iron in your body. Every trace of gold in the wedding bands of your grandparents. Every thin vein of silver in the ground. Every uranium atom anywhere was forged in the last flash of a giant. The periodic table is not a chart of chemistry. It is a chart of obituaries. The heavy elements are ashes. You are, in part, made from funerals. The calcium in your teeth. The iron in your blood. The iodine that tunes the rhythm of your thinking. Every one of these, at the scale of a single atom, is older than the planet you stand on. Each atom drifted for uncountable ages through cold, dark space after the giant that made it blew apart, until gravity gathered it, along with vast rivers of similar debris, into the cloud from which our sun and its worlds were formed. Reach up and touch your throat. You are touching material that was once at the center of a star that no longer exists. A star that burned itself empty, so that, much later, something soft and thinking could exist instead. What is it like to carry a piece of an ancient furnace inside you without ever feeling the heat? You have always carried it.
You will carry it until the day your own atoms are released again, back into the slow drift of the cosmos, waiting for their next appointment in some future cloud, some future star, some future possibility. And yet those funerals have a limit. Massive stars only formed in abundance in certain eras, in certain places, out of certain clouds. Every time one dies, a specific amount of the universe is permanently locked into remnants, into dead cores, into rapidly spinning neutron stars, into newly born black holes. That material rarely comes back. It does not return to the great pool of gas from which fresh giants could be born. It is taken off the board. The universe is, in this sense, slowly spending itself.
Every giant that falls removes raw material that might otherwise have lit another giant later. Every supernova closes a door behind itself. And so, as the ages pass, the giants grow rarer. Not suddenly, not noticeably, but unmistakably if you have patience measured in billions of years. There will come a time, still within the bright era, when the last truly massive star in a given galaxy is born. It will not know it is the last. Its nursery will look much like any other stellar nursery. A cold cloud, a knot of gas, a slow inward collapse under gravity, an ignition. It will burn fiercely, briefly, and then it will die, as its kind always do. But after it, no more giants. Not in that galaxy. Not ever.
Imagine standing on some silent world,
Many billions of years from now, in a galaxy that has already seen its final blue supergiant. The night sky above you is not empty. There are still stars, but they are all smaller, yellower, dimmer, or redder. The great violent lights that once punctuated the heavens are simply gone, replaced by slower, more patient flames. The sky has grown quieter, without anyone noticing. The symphony has lost its brass section. This is the twilight of the main sequence, the long, slow afternoon of the stellar age. The loudest voices have already left the room. Only the ordinary ones are still speaking, and eventually, only the softest. There is a strange dignity to this order. Bigger stars go first. Brighter stars go first.
The most dramatic, the most expensive, the most obviously spectacular flames pay the highest price for their drama. The quiet ones, the modest ones, the ones that never drew attention in any sky, outlive them by unthinkable margins. In the long run of the cosmos, the word legacy belongs not to the giants, but to the small. It is almost a kind of lesson, written in hydrogen. A star that shines too hard, too fast, does not get to shine long. A star that keeps its fire low and steady can keep it for ages no giant ever touches. And so, one by one, we watch the giants fall. In our galaxy, in the galaxy next door, in galaxies whose names no tongue has ever spoken and never will.
They go out like lamps being extinguished along a vast corridor, from the brightest toward the faintest, from the loudest toward the calmest. Each explosion in its moment seems to be the center of the universe. Each one, in the longer view, is only a step in a slow retreat of light. What does it feel like to be a voice that knows it will not last? You have, perhaps, felt a version of that feeling. A candle knows. A lantern knows. A giant star, if stars could know anything, would know most of all.
Now, lower your gaze. Forget the giants for a moment. They have gone, or they will go. Instead, turn toward the small, red, easily overlooked pinpoints that fill the sky in numbers beyond counting. These are the red dwarfs, the smallest true stars the universe allows. They are cooler than our sun, dimmer than our sun, less massive than our sun. Some of them are barely 8% of the sun's weight, scraping the absolute minimum of what it takes to ignite hydrogen at all. You cannot see most of them with the naked eye. Even the closest neighbors of our own sun, the handful of stars within just a few light years of Earth, are mostly red dwarfs. Quiet, red, faint.
Hiding in plain sight, beneath the threshold of ordinary human vision. And yet, of every 10 stars that exist in our galaxy, 7 or 8 are red dwarfs. The sky you see with your eyes is a heavily filtered sky. It shows you the loud ones.
And crucially, red dwarfs are almost entirely convective, meaning the star stirs itself thoroughly, carrying hydrogen from the outer layers down into the core and pulling helium ash back up.
where our sun will eventually choke on its own ashes and leave most of its hydrogen untouched in its outer layers. A red dwarf keeps mixing. It eats its entire pantry. Nothing is wasted. The result is a lifespan that dwarfs every other kind of star by orders of magnitude. Our sun may last 10 billion years. A blue giant, 10 million. A red dwarf can burn for trillions of years. The smallest ones, the very smallest, may shine for 10 trillion years, even longer.
If the age of the universe were a single day, a red dwarf's life would be several months. Every tiny red point you would see through a large telescope out in the cosmic suburbs is almost certainly a star that has burned less than 1% of its total lifetime. They are all, every one of them, young by their own clocks. No red dwarf has ever finished. None has ever ended as an old red dwarf. The universe is still, from their perspective, the first morning of the first day. And this is why they matter to the long story we are telling.
When the giants fall, when the suns swell and fade to white, when the planetary nebulae drift apart into wisps, when the bright names of the sky one by one go silent, the red dwarfs will still be here, burning low, burning patient, burning in numbers no eye will ever count. They are the watchkeepers. Long after the main sequence has thinned, long after the great violent dramas of the early cosmos have become memory, these small red flames will stand in the dark, unhurried. Their light will be soft, almost mournful, tinted deep red by their cool surfaces. Entire galaxies,
Imagine looking up at a night sky like that. Every star you see is red. Every star. There are no others left. The variety of the present is gone. The sky is a single slow color, the color of coals near the end of a long night. It is still beautiful. But it is a more austere beauty than the one you know. And still, even the red dwarfs are mortal. They burn slowly, but they do burn. Their fuel, vast as it is not limitless. One day, each one will reach the bottom of its pantry. Each one will begin to cool. Each one, in turn, will stop shining. But that day is so far ahead that the word future breaks under its weight.
We are talking about stretches of time so long that every current star, every current galaxy cluster, every current structure in the observable universe will have been rearranged, erased, or forgotten many times over before the red dwarfs are done. When the last red dwarf exhales its last thermonuclear breath, the cosmos around it will be unrecognizable. A different kind of place. A darker kind of place. That is where our story is going. Toward that last small red flame. Toward the final watchkeeper, alone in a night with no other stars to see. Toward the moment the universe becomes, for the first and last time, truly dark. But we are not there yet. Tonight, we are only at the beginning of the long dying.
We have watched the giants fall. We have watched our own sun's path to silence. We have learned that the loudest stars pay first, and the quietest stars pay last, and that the whole bright era of the cosmos is itself only a brief flicker in a much longer dark. The stage, now, is almost clear of drama. The giants have left. The sun-like stars are on their way out. What remains are the small, the steady, the patient. When the curtain rises on the next act, it rises on them. On the red dwarfs, alone with their long lives.
And somewhere in that quieter sky, though we cannot yet point to it, the last star is already being made. A cloud of gas, somewhere, is cooling. A knot inside it is tightening. A small red flame is preparing to light. A flame that will outlive all the others and be the final witness of a universe that once blazed. We will go there next, to the moment of that last ignition, to the final act of making in a cosmos that will never make again. Close your eyes if they are not already closed. The sky is still bright above you. It will be for a while yet, and while it is, the story continues, slowly, quietly, into the night where the red dwarfs keep their long watch alone.
Act I end. Total words 5083.
The stage is almost empty now. The blue giants are gone. The yellow suns, like our own, have long since shrunk into white embers. The orange stars that once warmed 1,000 quiet worlds have closed their eyes. What remains, drifting between the cold islands of what used to be galaxies, are the small ones. The patient ones. The red dwarfs. And something strange is happening to the sky. Imagine standing on a dead, airless world, 100 trillion years from now. You look up. You see almost nothing. Not because the darkness is full of stars too faint to notice, but because most of the stars have simply gone out. The night no longer breathes. It only waits.
There was once a raw material that made all of this possible. A thin, invisible fog of hydrogen and helium, draped across everything, older than the oldest galaxy. Every star you have ever seen, every planet, every ocean, every cell in your body was assembled from that fog. It was the dust from which all light was needed, and that fog is running out. In our era, a galaxy behaves like a careless kitchen. Stars are born, stars die, and when they die, they scatter fresh gas back into the room, seeding the next generation. The ashes of one star become the skin of another. Birth and death trade places constantly. It feels endless. It is not endless.
It only looks that way because we measure time in heartbeats, and the kitchen is closing slowly, course by course, over scales we were never built to feel. The useful hydrogen, the cold, dense hydrogen that can actually collapse under its own weight and ignite, is spent, locked away, or blown too thin to gather. Most of it now sits inside the corpses of older stars, white dwarfs that will never burn again, neutron stars too compact to share, black holes that swallow and return nothing. What floats free between the ruins is too warm, too diffuse, too lonely to fall together. Star formation does not end with a thunderclap. It ends with a slow, silent starvation.
Somewhere, in a quiet corner of what used to be a galaxy, one last reservoir survives. A thin, cold cloud. Not glamorous, not vast. Maybe no larger than the orbit of a forgotten planet. It has been drifting for ages, untouched, overlooked, a final teaspoon of the primordial fog. It contains just enough mass to make one more star. A small one, a humble one. The kind that would have been ignored in any earlier era. And gravity, which has all the time in the world, begins to pull. There is no witness. There is no rush. The cloud contracts over epochs so long that whole galaxies could rise and fall within a single moment of its collapse. Slowly, its core grows denser. Slowly, its heart grows warmer.
Hydrogen atoms, strangers for 100 trillion years, are pressed into each other's company. And then, at the end of a silence longer than any story ever told, something astonishing happens. A proton slips past its own electric fear. It falls into another proton. It fuses. The last star ignites. It is not a spectacular birth. No supernova applauds. No neighboring suns turn to watch. The star is a red dwarf, perhaps 1/10 the mass of our own sun, glowing a sullen crimson, barely warm enough to be called a star at all. If you placed it where our sun now stands, it would look like a coal, a faintly breathing coal suspended in an ocean of black. But it is, in every sense that matters, the final lamp.
Think about what this means. Every fire that will ever be lit in this universe, every furnace of hydrogen, every engine of nuclear light, all of it ends at this small red heart. After this, the cosmos will manufacture no new stars. Not in 1,000,000 years. Not in 1,000,000,000. Not ever. The word ever is rarely used honestly. Here, it is exact. Let the scale settle on you for a moment. The Earth, beneath your feet, is 4.5 billion years old. The oldest galaxies have lit the sky for about 13 billion years. That entire history, every supernova, every star nursery, every sunrise on every world, occupies a narrow band near the beginning of time.
100 trillion years from now, that band has receded into a forgotten prologue. We are living in the first chapter of a book whose middle is almost entirely cold. The final red dwarf knows none of this. It is simply burning. In its crushed core, 4 hydrogen atoms at a time are folded into helium, releasing the same faint, indifferent energy that lit our own sun. Its surface temperature hovers around that of a dim ember. Its light is so deep and low that, to human eyes, it would look almost like a wound in the dark, a slow-beating pulse in a sky that has forgotten how to blink. Around it, perhaps, are a few cold worlds. They were never warm to begin with.
They were not born. They were gathered. Lumps of iron and rock and frozen gas, sifted from the same doomed cloud. They do not have oceans. They have never had oceans. They have never had names. They drift around their tiny parent in obedient, slow circles, and their surfaces remember nothing, because there is nothing to remember. From above, if some impossible traveler passed through this region, the view would be eerily simple. One red point, barely more vivid than a nearby candle. A handful of dark companions,
And then, in every direction, a sky that seems almost clean. No rival suns, no glowing arms of spiral galaxies, no ghostly bands of light.
Only the deep, cold background, and the knowledge that every other star still alive is too far away to share its glow. This is not an empty universe. It is an emptied one, a place that used to be crowded, a place that has been steadily, patiently unbuilt. And the cruelest, strangest detail is this: the last star is not special. It does not look different from the red dwarfs of our own age. It is not larger, or brighter, or wiser. It has no mark upon it. Nothing in its physics whispers, "You are the final one." It simply is. A small, ordinary star, burning as all stars burn, until it cannot. How long will it live? That is the next terror. A red dwarf does not hurry.
With so little mass, it can stretch one load of hydrogen across unimaginable spans of time. Our sun will burn for about 10 billion years. A star this small can burn for trillions. 10 trillion, 20, perhaps more. Its heart will beat so slowly that the ages between each breath of fusion are longer than the life of a galaxy. It has inherited all of eternity's patience, and nothing else. After this star, the universe never ignites again. No protostar will ever contract. No fusion reaction will ever begin. The sky will hold only fading coals. The words new light will lose their meaning. Poets, if there were any left, would have to invent a different language. Close your eyes for a moment. Let the weight settle.
After this, no more beginnings, no more first sparks, no more cradles. The last star has lit itself in a dark room, and it does not know that the door has closed behind it. Consider for a moment what is missing from the sky around it. In our own age, on a clear night far from any city, the human eye can gather perhaps 3,000 stars. Each of those pinpricks is a furnace, a working sun, some of them 1,000 times more luminous than our own. That crowded sky is not a decoration. It is a record of an extraordinarily busy universe, still manufacturing light at a furious rate. Now erase it, all of it, not one by one, but as a category. Around the last red dwarf, there is no Milky Way glowing softly overhead. There are no familiar constellations. There is no band of other galaxies spread across the night like a slow silver tide. Expansion, over 100 trillion years, has pushed every other galaxy so far away, so fast, that their light will never again reach this spot. The observable universe has shrunk around the last star like a room around a single lamp. Beyond the edge of that shrinking room, the rest of the cosmos still exists, in some sense, but it is locked out, severed by the speed of its own retreat. It is the loneliness of geometry itself. And yet, the small red star, unaware, keeps fusing.
It does not know that its neighbors have been stripped away. It does not know that its own sky is closing. It simply does what stars do. It presses hydrogen into helium
and in exchange releases the thin, patient glow that is the entire inheritance of every flame that ever was. One lamp, one last, stubborn lamp, in a night without edges.
We come now to a moment without precedent. The last star is burning. Not furiously, not brilliantly. It burns the way a coal buried under ashes burns. Slowly, faintly, almost grudgingly. But it burns. For trillion after trillion of years, it keeps its tiny furnace alive. Its core, compressed by its own weight, stirs hydrogen into helium at a rate so gentle that from outside you might mistake the star for dead. It is not dead. It is merely frugal. Consider the scale, because it is the scale that undoes the mind. 100 trillion years has already passed since the age of ordinary stars began to fade. 100 trillion, a 1 followed by 14 zeros.
That number alone is 10,000 times the current age of the universe. And yet, in the life of the last red dwarf, this is only the opening act. The star will go on burning for another 10, perhaps 20 trillion years. It will outlast by itself more time than the entire history of galaxies before it. While it burns, changes you and I would call cosmic have stopped happening. The other red dwarfs, its distant cousins, have one by one slipped out of fusion and faded into white dwarfs. The last supernova has long since flickered out. The last gamma-ray burst happened so long ago that its light has since been diluted into nothing. The universe has become a patient room. Only one lamp is on.
Now imagine yourself drifting near this final red dwarf. I know this is not possible. I know that no creature of flesh could ever be there. But allow the thought experiment, because that is the only way the scale becomes real. You float near the star. Its light is a deep, saturated red, almost the color of old embers when the fireplace is dying. The warmth on your face, if you could feel it, would be faint. Not the blazing press of a summer sun. Something gentler, stranger. Like holding your hand near a candle you are not sure is lit. The sky around the star is nearly empty. No nebulae. No drifting arms of dust. No new worlds condensing from anything.
Everything that could condense has already done so 100 trillion years ago. And then, inside the star, one small equation begins to go wrong. The core has been gathering helium for an eternity. Helium is the ash of hydrogen fusion. And like all ash, it smothers its own fire. The star starts.
But there is a last breath, even for the most patient of lungs. Slowly, over the course of another trillion years, the hydrogen supply thins beyond rescue. The core can no longer find enough fuel to sustain even the slow, whispering fusion it has practiced for so long. The star contracts again, but now the contraction does not reignite anything new. It only tightens the emptiness. And then, quietly, the final reaction ends. There is no flash, no shell of expelled gas, no nebula to paint the dark.
A red dwarf this small cannot even rise into a red giant. It cannot form a planetary nebula. It cannot explode. It simply stops.
In the place where fusion once burned, where light itself was being manufactured atom by atom for trillions of years, there is now only a hot, dense knot of helium and hydrogen remnants shining on borrowed heat. For a little while, it still glows. Then, steadily, the glow dims. From outside, the final flame does not go out the way a light bulb goes out, suddenly and with a click. It fades the way a dying ember fades, red to dull red to dark red to a color that is not really a color anymore. The star becomes a smoldering relic, a warm corpse, a cinder.
And now listen carefully, because something is about to happen for the first time in the history of everything. Somewhere in the observable universe, the count of stars drops to 0. Let that sentence rest. For 13.5 billion years, the night sky has always had stars in it. From the first primordial giants of the young cosmos, to the brilliant clusters of the stellar age, to the lonely red dwarfs of the long twilight. At every moment, somewhere, some star has been burning. Even in the darkest valleys of cosmic history, there has been a candle lit. Now there is none. The sky, if any eye could still see it, is not merely dark.
It is the kind of dark that has no memory of light. There is no star rising anywhere. There is no star setting. There is no daylight waiting on the other side of any world. The galaxies are gone in any meaningful sense, long since dispersed, their corpses drifting apart faster than any traveler could catch. And above all of it, the absence of any source. It is a silence of a sort, a silence so absolute that no ear could grasp it, because a silence usually lives inside a world, and here there is no world left that cares. There is no language. We invented words for the hush after a storm, for the calm after a heartbreak, for the stillness of a forest at dawn. We never invented a word for the cosmos closing its eyes. Even stranger, perhaps, is this: no one is watching. There is no civilization to record the moment, no last astronomer on some last world, squinting through some last telescope to note the time. No machine sending a final signal into the void. Life, in any form we would recognize, stopped being possible somewhere deep in the twilight, when worlds froze and star systems dispersed. The final extinction of fusion in the universe happens without ceremony, without a name, without an audience. A candle, alone in an empty room, going out in the middle of the night.
And yet, from a certain angle, this moment is not grim. It is almost tender. The universe has run its metabolism fully through. It has done with its hydrogen what hydrogen was always going to do. It has built suns and planets, and here and there, brief flashes of life that wondered about themselves. It has spent every drop of its original brightness, and now, emptied, it rests. We are tempted to call it death, but death is something that happens to the living. What happens here is something else. It is a deeper, quiet, a closing. If you were somehow there to hear the last fusion event, you would hear nothing. Space does not carry sound.
But even your inner ear, the part of you that hears silence itself, would feel something shift, like the moment in a vast hall when the last person exhales and finally stops speaking. After this, no new photons from any star, only the cooling ghosts of the old ones, only the faint glow of bodies too stubborn or too confused to forget they used to burn, and the night which began long ago as a thin veil between suns has finally become the entire universe. Try, if you can bear to, a single thought experiment before we move on. Imagine that, by some impossible grace, one human eye is permitted to witness the moment, not a telescope, not an instrument.
Just an eye. Yours, perhaps, borrowed across 1,000 lifetimes and placed, without explanation, at the edge of the last star's orbit. You are given 1 minute. The cosmic clock reads 100 trillion years past the Big Bang. You look. You see the red dwarf finish. You see its crimson light soften, thin, and give up. You see the glow hold, for a while, in the heated carcass of the former star. You see, and this is the strangest part, nothing else. No sun rising somewhere on a distant world. No star pulsing behind the darkness. The sky, in all directions, is flat and black and honest. Then your minute ends, and you are returned to this night, this century, this heartbeat.
And the universe, which you briefly watched exhale, continues without you. I tell you this because the final flame is not abstract. It is a specific event at a specific moment in a specific place. It happens. It is allowed to happen. The physics of our own kitchen, our own sun, our own quiet evenings, taken far enough in time, leads directly to it. What ends there is not a metaphor. It is simply every star, including, much earlier, our own. The universe closes its last eye, and the dark inherits everything.
The stars are gone. The story, strangely, is not. We now enter the degenerate era, a name astrophysicists chose carefully. Not degenerate in any moral sense. In their language, it describes a particular kind of matter, matter squeezed so tightly that quantum rules, not thermal pressure, hold it together. White dwarfs are degenerate. Neutron stars are degenerate. Much of what remains in this frozen universe is held together by physics more stubborn than heat. This is the era of corpses, and it lasts, by any human measure, forever. Set your internal clock. The last star has gone out somewhere around 100 trillion years after the Big Bang. The degenerate era stretches from there until roughly 10 to the 40th power years. Write that number down.
1 followed by 40 zeros. If you tried to count those years, 1 per second, faster than any human mouth could pronounce them, you would not finish before the universe itself ended. The number is not a number. It is a prayer with too many syllables. What lives here, in this vast, quiet graveyard? Let us walk through it slowly. First, the white dwarfs. Once the cores of sun-like stars, they are small, dense, glittering orbs about the size of the Earth, but with masses close to that of our sun.
At the beginning of this era, they still glow faintly. Leftover warmth from when they were stellar hearts. A hand on their surface, if such a thing were possible, would sense a kind of sullen, residual heat.
They are like stones pulled from a dying fire, still too warm to hold, even though the fire is long out. Next, the neutron stars. These are even stranger. Dead in name, but built of a substance so dense that a single teaspoon of their interior would weigh more than a mountain. They are the compacted hearts of stars that once died violently, long before the last red dwarf was born. By this era, most of them have cooled into dim magnetized spheres, slowly rotating, slowly forgetting. Occasionally one still emits a faint radio pulse, a ghost of an old rhythm, though no one by now is listening. Then, the black holes. We will not speak of them long here, because they have an era of their own to come.
For now, understand only this. They are patient, and they are hungry. And in this landscape of cooling ruins, they are among the few things that are still, in any meaningful sense, alive. They drift, they swallow the occasional unlucky wanderer, and they wait. And then the small bodies. Brown dwarfs, objects too small to ever have been stars at all, failed suns, caught between planet and flame.
The universe has become a vast, dim mortuary, and most of its furniture is made of corpses. But do not imagine it as perfectly still. Every now and then, and I use the phrase every now and then in a sense that would terrify a human calendar, something happens. Two neutron stars, drifting through the emptiness, cross each other's paths. Their gravity bends. They spiral in. Over the course of millions of years, they lock together. And when they finally collide, there is a flash. A short, violent burst of radiation. Brief, but real. Tearing across the silence, like a match struck in a cathedral. A gamma ray burst, a gravitational tremor, a handful of new atoms forged in the chaos.
One more spark in a universe that thought it had forgotten how to spark. Or imagine this: a white dwarf and a black hole, entangled by ancient gravity, draw closer over ages. Eventually, the white dwarf is torn apart, its matter spiraling down into the black hole. For a moment, the accretion glows. A tiny, improbable sun made of death instead of birth. Then it is gone. These are the last fireworks. They are rare. They are far apart. On any given human timescale, nothing happens for epochs.
You would wait and wait and wait and see nothing, until you had forgotten you were waiting. And then, once every trillion years or so in some distant corner, a flash, a pop, a brief, confused brilliance. The universe has become a cemetery where every 1,000 centuries, a lantern blows out improperly, and in doing so somehow lights itself. A cemetery that occasionally, almost by accident, glows. Picture the sky again during this era. The light of the last few dying embers is so weak that even standing near them, you would barely see by their glow. The universe is much colder than anything you have ever touched.
The background itself, the ancient afterglow of the Big Bang, has cooled from the modest chill of 3 degrees above absolute zero into fractions of a degree. Space is not merely cold, it is approaching the definition of cold. Touch, if you could, a white dwarf from the middle of this era. Your fingers would not recoil from heat, they would stiffen from absence. The stone that once powered a civilization's daylight is now a pebble that could not warm a moth. And yet, against all of this, there is a strange beauty in the picture. A universe made of its own ashes, lit softly from within, drifting apart at speeds that only grow year after unimaginable year.
The dead bodies of stars shining with their own slowly fading heat, as if the cosmos, after its wild youth, has finally learned how to be still. This is the degenerate era, the universe's long afternoon, where afternoon means 100,000 billion trillion years, a place where change has become so rare that rarity itself is the main event. And we are only beginning. One more image. Before we move on, to hold in your mind as you drift through this chapter. Picture a galaxy, or rather, what used to be a galaxy. Long ago, its spiral arms were studded with young blue giants and warm, ordinary suns. Now there are no arms. Gravity, over such immense spans, has disassembled the spiral.
What remains is a loose, drifting cloud of stellar corpses, spread across distances that used to hold 100,000 shining stars. Between the corpses, mostly empty space. Between the galaxies, unfillable gulfs. A passing traveler would not call this a galaxy anymore. They might call it a fog bank, a memory of structure, a slowly thinning archive of what used to be a place. The gravitational center still exists, more or less, but there is no longer anything bright enough to trace the shape. The old spiral sleeps beneath the dark, like the outline of a city buried in snow. And this, multiplied across the whole observable universe, is the degenerate era. Not empty, not even dead, exactly, simply past.
A universe that has finished most of its work and is spending its retirement by the slowest, coldest window.
There is a kind of death that is not dramatic. A white dwarf, remember, is the still warm corpse of a star like our sun. When our own sun reaches the end of its life, some 5 billion years from now, what it leaves behind will not be empty space. It will be a dense, glowing remnant about the size of the Earth, its outer layers stripped away, its core exposed. For a while, that remnant will shine faintly from leftover heat. It has no furnace. It is simply a hot, packed stone, radiating away an inheritance. And it will cool. Slowly. Very slowly. A white dwarf has no heat source of its own. It is an object that used to burn and no longer does.
Left alone, all it can do is release its stored warmth into the dark, photon by photon, for an absurd span of time. Current physics suggests it takes on the order of 10 to the 15th power years for a white dwarf to radiate away enough heat to cool down to the temperature of the cosmic background. That faint universe, filling echo of the Big Bang. 10 to the 15th power, a quadrillion years. A number large enough that the age of our universe today fits inside it about 100,000 times. By that point, a white dwarf has become, in theory, a black dwarf. A stellar corpse that has completely surrendered its last trace of warmth, gone so cold that it no longer emits any visible light at all. A dead, dark, planet-sized diamond drifting in infinite night. And here is the trap. The universe itself does not stand still while the white dwarf cools. The universe keeps expanding. The ancient background radiation keeps thinning, stretching, cooling. Space grows colder, year by unimaginable year. And the finish line, the temperature the white dwarf is trying to reach, keeps receding. It is as if a runner is trying to catch up to a shadow, while the shadow slips further away each step. For countless ages, this means something strange. The white dwarf, although a corpse, is paradoxically warmer than the universe around it.
It is the only warm thing in its neighborhood. Its tiny, leaking glow is, in a sense, the only warmth for light years in every direction. A universe ruled by cold, with a few dim stones still whispering heat. And eventually, after a stretch of time so enormous that our mathematics, not our imagination, has to hold it for us, the white dwarf catches up. It has finally cooled to match the bath around it. It no longer radiates any net energy. It is in the purest sense, invisible. A black dwarf is born. Not born, really. More like quietly named. It has been drifting all along. It has done nothing dramatic. It has simply surrendered the last tremor of its ancient fire.
Here is a thought that should unsettle you a little. Today, in our era, no black dwarf exists. Not one. The universe is too young. There has not yet been enough time for even the first white dwarfs to cool that far. Every dying star that has ever closed its eyes since the beginning of time is still, in some faint way, glowing. Every stellar corpse is still warm. The black dwarf is a future species of object. It waits in the possibility of physics, the way a sentence waits in a book that has not yet been written. 100 trillion years from the Big Bang, there are still no true black dwarfs, only cooling white ones.
10 to the 15th power years from now, the first ones begin to appear.
By then, if you could drift through the degenerate era's later stretches, you would find the sky utterly without light. All the stellar corpses have matched the cold. Every diamond has surrendered its last shimmer. You would be floating in a universe that has made peace with absolute invisibility. And here is the quiet detail that might be the saddest thing in all of cosmology. A black dwarf does not die. It simply disappears into the dark because the dark has finally caught up with it. Nothing ended. Nothing broke. The object is still there.
You could, in principle, reach out and touch it. A crystalline, fossilized cinder, old enough to confuse the word old. But you would not see it. You would not feel it. You would not know it was there. It is a dying that is indistinguishable from a never having been. Think of a candle, lit at the beginning of a long night, inside a room that keeps getting colder. For a while the candle warms the room. Then the candle burns down to a stub. Then the stub cools. Then the walls of the room cool faster than the stub can. The stub keeps giving up its heat to match the walls, and the walls keep giving up theirs to match the void.
Eventually, the candle and the walls and the void are the same temperature. The candle has not vanished. It is simply, in every sense that mattered, no longer a candle. That is what happens to the white dwarfs. And across the universe, at rates almost too slow to describe, the roll call of black dwarfs grows. One former star after another slips past that final threshold, and the count of invisible corpses ticks upward. A census no one keeps.
It is only a chapter in an ending, because even these cold, dark, seemingly inert remnants will not last forever. Something deeper is coming for them. Something no physics teacher on any earlier world could have predicted without a little fear in their voice. Matter itself, perhaps. We have spoken of stars dying. We have spoken of corpses cooling. We have imagined, as far as we could, a universe of silent, invisible remnants drifting through an ever colder dark. Now we have to speak of something stranger. For most of human history, we believed matter was eternal. A rock is a rock. Atoms are atoms. The bricks of the world are permanent. Only their arrangements change. A vase may shatter, but the clay remains. A body may dissolve, but its atoms persist, recycled into new rivers and new creatures. The idea of permanence is woven so deeply into our intuition that we rarely question it. But physics, the strange, patient discipline that keeps telling us,
according to a class of theories called grand unified theories, the proton, the tiny, positively charged particle that sits at the heart of every atom, is not truly immortal. It is only extremely long-lived. Left entirely alone, a proton is expected to eventually decay, to unravel, to become something simpler than itself. The predicted timescale is almost laughable. Somewhere between 10 to the 34th power years and 10 to the 40th power years. That is a 1 followed by 34 to 40 zeros.
To give you a sense of how empty that number is of human meaning, if every second of the current age of the universe were itself a full universe, and you stacked those stacked universes on top of each other, billions upon billions of times, you still would not be close. Our language has not been built for that room. Our arithmetic can hold it, but only as a symbol. The symbol points to a silence. Now, imagine what this means, scattered across the already quiet universe. In the later ages of the degenerate era, the universe is full of white dwarfs, black dwarfs, neutron stars, stray planets, lonely comets, drifting boulders. Every one of them made of atoms, every atom full of protons, every proton, perhaps, secretly unstable.
They are waiting, without knowing they are waiting. Then, somewhere inside one of those old stones, a single proton decays. It does so almost silently. It emits a tiny burst of particles. A positron, perhaps, a pion. Eventually some photons and lighter debris. The pion decays into smaller bits. The positron meets an electron somewhere, and the two annihilate, releasing a faint, clean flash of energy. A little whisper of light inside a stone that has been dark for ages. Then another proton decays, far away, in another corpse, and another, and another. Over 10 to the 36th power years, the whole census of matter begins to thin.
A neutron star that used to be a mountain of dense packed nucleons begins to lose them, one at a time, evaporating, not in the usual sense of heat, but in the sense of ontology. Its particles cease to exist as the kinds of particles they were. A black dwarf, invisible, frozen, slowly shrinks, not because anything strikes it, but because its building blocks themselves are quietly retiring. A planet the size of Earth, drifting alone in the absolute night, drizzles itself away atom by atom across scales of time we cannot name. It becomes smaller, and smaller, and smaller. Imagine, if you can, a world shedding its own self across eons.
Every 1,000 billion trillion years, a tiny crumb of it gives up the notion of being matter and becomes, instead, a faint puff of radiation and a few light particles. The world does not explode. It does not rot. It evaporates, in the way fog evaporates, except it is solid, and the fog is made of everything it is. Eventually, after a span of time that makes even the degenerate era look short, these remnants are gone, not broken, not buried, dissolved. The white dwarfs are gone. The black dwarfs are gone. The neutron stars are gone. The cold planets, the frozen gas, the rubble, the dust, all gone.
Every atom that anyone or anything ever built anything out of has surrendered its particles back into a thinner, simpler kind of existence. Matter itself, in the form we know it, has forgotten how to hold together. What remains? Photons. Light, in the loosest sense of the word, though most of it is too stretched, too red-shifted, too diluted to illuminate anything. Neutrinos, fleeing in every direction, as they always have. Electrons and positrons, floating in a kind of thin, charged fog. And, still, untouched, unbothered by this decay, the black holes. Because the black holes are not made of the same stuff. Their interiors are beyond the reach of proton decay. They are immune to this particular kind of forgetting.
In other words, when matter unravels, the only structures left standing are the wounds in space-time. Sit with this, if you can. The cosmos began in a blaze of hot, undifferentiated particles. It cooled into matter, into atoms, into stars, into worlds, into all the complexity we know. And now, across a scale of time too vast to say aloud, it undoes that work. It returns, step by step, to simplicity. Not the simplicity of the beginning. That was a simplicity of heat and crowding, but a new simplicity, made of distance and quiet. A universe that no longer bothers with matter. Some physicists, it is worth noting, believe the proton might not decay at all.
They believe that grand unification may be wrong, or that the proton's lifetime is effectively infinite. If they are correct, then the story bends differently. The dead stars remain, the black dwarfs drift on, the cold corpses refuse to dissolve. But even in that gentler story, the black holes still come for them, over slower, stranger processes. Either way, the matter does not keep forever. Either by decay or by capture, the atoms will go. And here is a moment to breathe. A small, absurd moment.
Right now, at this very instant, not 1 trillion years from now, not 100 trillion years from now, but right now, as you sit in whatever quiet place this voice finds you, the protons inside your body, your chair, your walls, the glass of water beside you, are already, perhaps very slowly, unraveling. None of them have vanished in your lifetime. None will vanish for an unthinkable lifetime of the universe. But the process, if it exists, is running. The tiniest, faintest, most statistical of erasures is already at work. You are in the deepest physics, a candle that has not yet noticed it is burning. This, for me, is the quiet heart of this chapter.
Not that the universe ends. That has been whispered for millennia, but that its very materials are themselves provisional. We spoke earlier of stars running out, then of corpses cooling, then of corpses blending invisibly into the dark. Now we speak of the corpses not merely hiding, but forgetting how to be corpses at all. After matter is gone, the universe becomes a thin, almost dreamlike place. An ocean of faint radiation, a mist of leptons, a background so cold and so stretched that the word full barely applies. And in this near vacuum, drifting across distances that no language can stage, the last structures survive. The last objects that still count themselves as something. The last things with weight, with gravity, with an inside. The black holes.
Oh, huge, silent, patient. They have watched this entire disassembly without comment. Stars burned and faded. They did nothing. Red dwarfs ignited their final lamps. They did nothing. White dwarfs cooled into black. They did nothing. Planets drifted and evaporated their very atoms. They did nothing. And yet, all that time, they were growing by slow accretion, by quiet mergers, by a patience that outweighs everything. Now the cosmos is empty enough that they are, finally, the main characters. Whatever else follows, the slow bleed of Hawking radiation, the collapse of the last horizon, the deep, strange possibilities of true nothing. It will belong to them. The universe has forgotten how to be matter. It still remembers, for a little longer, how to be gravity.
Acted 2 end. Total words 6,640.
The last proton has unraveled. The universe is no longer made of things. It is made of distance. Take a breath. Let it slow. Picture the cosmos you just left behind in Act 2. The final black dwarf has dissolved into leptons and light. The atoms that once built suns and planets, and the bones of every creature that ever lived, have all quietly come undone. Space stretches on, vast beyond any measure, filled with nothing but a thin fog of photons, neutrinos, and lonely electrons, drifting too far apart to ever meet again. And yet, across that emptiness, something still holds its shape. They are older than the light, older than the stars that gave them birth. They are the black holes.
The time is 10 to the 40th power years after the beginning, one followed by 40 zeros, a number so large that if you wrote 1 0 every second, you would finish long after the Earth had already died. And this, in the life of a black hole, is only the beginning of middle age. Imagine drifting through this era. You move for 1 billion years in any direction, and you see nothing. No star, no nebula, no warmth. Then, a subtle tug on your path, a curvature so gentle it feels like a whisper. You follow it, patient as a river, and 1,000 millennia later, you arrive at a shape that is not a shape. A region where light bends back on itself.
A stillness that is also a hunger. This is all that is left of a galaxy. The black holes have inherited the universe. Some are small, no more massive than a single dead sun, formed long ago when a giant star collapsed in the final spasm of Act 1. Others are monstrous, millions or billions of solar masses, the quiet sovereigns that once sat at the heart of every galaxy, feasting on gas and stars. When the galaxies themselves dissolved, these sovereigns simply remained, drifting like unlit lighthouses on an ocean without shores. Think of how strange this inheritance is. In the human era, black holes were monsters, things to fear, things to study from an enormous distance. They tore apart stars. They bent the fabric of space.
They were rumored to swallow information itself. And yet, in this long twilight, they are the gentlest objects in creation. There is nothing left for them to devour. No gas to pull, no dust to gather, no companion sun to tear apart in a screaming accretion disk. They have become, almost by accident, the patient monks of the universe. Still, silent, contemplating nothing in particular. They have outlived the stars that made them. They have outlived the galaxies that hosted them. They have outlived the atoms themselves. And they are not done yet. In this era, there is no news. There are no events. A black hole can go for 10,000 trillion years without swallowing so much as a single wandering photon.
Space has become too thin to feed them, and so they do something almost unimaginable for an object that was once the very symbol of appetite. They begin, very slowly, to die. You have heard the name before, Hawking radiation. In the human era, it was a footnote in textbooks, a curiosity for specialists. Here, in the age of black holes, it is the central drama of the cosmos.
Near the event horizon, the vacuum is not truly empty. It trembles with pairs of virtual particles, flickering in and out of existence faster than thought. Most of them annihilate each other and vanish. But at the edge of a black hole, sometimes one partner falls inward and the other escapes outward, carrying away a little sliver of warmth.
To the distant universe, it looks as if the black hole is glowing. Very faintly, very patiently. A thermal whisper, far colder than the coldest winter you could imagine. Hold this picture in your mind. The black hole does not feel itself leaking. It cannot. The event horizon is a one-way door, and the radiation is born at the threshold, not inside. From the black hole's own point of view, if such a thing could exist, nothing is happening. It is simply sitting there, doing what it has always done. But from the outside, a slow thread of warmth unwinds from its surface, and as that warmth leaves, mass leaves with it. Energy and mass are the same quantity wearing different clothes. To bleed one is to bleed the other.
A stellar mass black hole, weighing as much as a handful of suns, radiates at a temperature of roughly 60 nanokelvin, colder than the background of the universe in our own age, colder, very nearly, than the void itself, and yet, the leak is real. Every photon that departs carries away a tiny amount of mass. The black hole shrinks, not in a moment, not in an age. Over timescales so long the words stretch like taffy in the mouth. A small primordial black hole, one forged in the first seconds after the Big Bang with the mass of a mountain, has long since evaporated. That happened in Act 1, before you or I would ever have noticed. The stellar mass black holes take 10 to the 67th power years.
10 duotrigontillion years. A number so enormous that the entire previous history of the cosmos, every moment from the Big Bang to the end of proton decay, fits inside it like a single raindrop inside an ocean. And the great ones, the supermassive black holes that once ruled the galactic centers, they last even longer. A black hole 1 billion times the mass of the Sun requires about 10 to the 100th power years to fully evaporate. 10 Google years. A 1 followed by 100 zeros. A number with no name in any human language old enough to matter. They are not eternal, but they are the closest thing to eternal the universe will ever make. Let that scale sink in.
If you took the entire age of the universe at the start of Act 1, the 13.5 billion years that carry us from the Big Bang to your own lifetime, and you counted it as a single heartbeat, then the lifetime of a supermassive black hole would be billions upon billions upon billions of heartbeats. And even that comparison falls short, because each of those heartbeats contains itself billions of heartbeats, recursively, until the language fails. There is no human way to feel a number this large. You can only circle it, the way a moth circles a candle it cannot understand. And through all of that, the black hole just sits, not thinking, not waiting, simply being. Consider the rhythm of this dying. For the first 99% of its long life, a black hole barely changes. It simply floats, radiating a trickle of warmth into a cosmos that is already colder than anything it emits. Nothing sees the light. Nothing receives the message. It is a lighthouse shining for an empty ocean, forever.
Then, in the final sliver of its lifetime, something accelerates. As the black hole shrinks, it grows hotter. A runaway spiral begins. The evaporation, which took ages upon ages to do almost nothing, suddenly quickens. The last kilogram of mass leaves in a flare that is almost violent, almost beautiful, a short burst of gamma rays released into an otherwise dark sky. And then, nothing. The black hole is gone.
The patch of space where it once lived is as empty as any other patch of space. No ripple, no echo, no monument. Imagine the funeral procession. First, the small stellar mass black holes go one by one in a drizzle of final flares. They have been dying quietly for ages, each one announcing its departure with a single pulse, a pulse no one will see. Then, after eons more, the intermediate black holes join them. And eventually, on timescales that dwarf even the timescale of proton decay, the supermassive ones begin their final acceleration. They have waited longer than any other object in creation. They have outlasted every rival.
The cosmos was built up, atom by atom, star by star, galaxy by galaxy. Now it is being taken apart, black hole by black hole, photon by photon. Subtraction is slower than creation. It always is. Creation can happen in a flash of condensing gas. Subtraction requires the patient drip of a tap that was never turned on. But subtraction is more thorough. It leaves nothing behind. Not even, eventually, the stage on which the drama was performed. Try to feel the enormity of this. In the human era, we speak of things that last. A mountain, a species, a star. We borrow the word forever, because the true timescales frighten us.
But here, in this chapter of the cosmos, even the most permanent object physics has ever imagined is coming undone, one photon at a time. A human lifetime is a candle. A civilization is a brief season. A star is a long afternoon. A galaxy is a single lazy breath. And a black hole, the thing we once feared as eternal, is a slow exhale whose ending we can already, mathematically, predict. Each scale dwarfs the one before it. Each scale is, from the next one's point of view, almost nothing. The universe has arranged its objects in a quiet hierarchy of endings. Even eternity, it turns out, has a lifespan.
There is one left. Somewhere in the enormity of expanded space, one final object holds on. A supermassive black hole, the largest the universe ever produced. Once, it anchored the core of a titanic galaxy, surrounded by a halo of 100 billion stars. The stars are gone. The galaxy is gone. The neighbors have long since evaporated into cold thermal glow. And yet this one remains, quietly shedding heat, shedding mass, shedding time. The clock now reads something close to 10 to the 100th power years. Imagine that number as a ladder, each rung 10 times taller than the one below it. You would have to climb 100 rungs to reach this moment. At rung 13, you have already passed the present age of the universe.
At rung 40, every proton in every atom that ever existed has decayed into leptons. At rung 67, the last stellar mass black hole has quietly winked out. And still, you would have to keep climbing, decade after decade after decade, to arrive here. Here, where the last black hole is about to release its final photon. Picture it, if you can. The sky, if there were anything to call a sky, is perfectly dark. The temperature of the surrounding vacuum is effectively zero. Space has expanded so violently that any remaining particle is separated from its nearest cousin by distances that dwarf the observable universe of our own era. You could travel for 10, followed by 50 zeros of years in a straight line, and encounter no matter at all.
The universe, by any honest measure, has become an abstraction of itself. Try to walk around this object in your mind. There is nothing to walk on, no planet beneath your feet, no background of stars to orient by. You are suspended in a pure black volume whose size is meaningless, because nothing else exists to give it scale. And at the only point of interest in this entire cosmos, a tiny knot of curved spacetime holds itself together by habit more than by physics. And in this abstraction, a faint pinprick of warmth. The last black hole is now as small as a dust grain, then as small as a molecule. Its temperature climbs as its mass falls.
In its final seconds, by its own internal clock, it is hotter than the core of any star that ever burned. A sudden blaze of radiation, a soft pulse of gamma, a shiver through the empty fabric of space. The final seconds are the loudest seconds of its life, in a universe that has been cold for longer than any word can express. A tiny point of heat briefly flares brighter than a sun. It is the cosmos clearing its throat one last time. A short, astonishing sentence in a language no one remembers. And then the sentence ends. The radiation peels away. The curvature smooths out. The region of space where the black hole used to be is, suddenly, indistinguishable from the region of space around it.
And then, the last photon. Think about this single particle. It carries with it the final unit of energy that the black hole ever possessed. Inside that energy, in principle, is encoded the memory of everything the black hole ever swallowed. Every star, every world, every letter ever written on those worlds, every song ever sung. If the information is truly preserved, as most modern theories insist, then this photon is a library compressed into a whisper. Consider what that library might contain. The light of a first sunrise on a world whose continents you will never name. The warmth of a body curled against another body on a night 10 billion years before your birth.
The chemical signature of a forest whose trees never had a word in any language. The last thought of a creature that lived and died long before the black hole ever opened its mouth. All of it, compressed, entangled, mathematically preserved, rolled into the single note of a final photon, leaving the last horizon. But it flies into a universe with no readers. There is nothing to catch it, no atom to absorb its energy, no mind to interpret its spectrum. The expansion of space continues to stretch its wavelength, longer and longer, colder and colder, until it is a ripple so faint it can never meaningfully interact with anything again. The last message the cosmos ever sends is addressed to no one, and it will travel forever.
Let that word settle. Forever. In the human era, the word was used lightly. People promised each other forever. They carved forever into stone, into rings, into vows. They did not mean it the way the photon means it. The photon does not promise. It simply continues. Its clock slows with the stretching of space, but it never arrives. It never rests. It carries the last warmth of the last concentrated object out into a void whose edges retreat faster than the photon can ever chase them. Think about the quietness of this. A message dispatched with perfect precision that can never arrive. A signal that will never cross a threshold.
A word spoken into a room where no one is listening, and then the room itself drifts apart, and the word with it. The photon does not know that there is no receiver. It just keeps moving, obedient, steady, dutiful, until its own energy falls below any meaningful value, and it becomes indistinguishable from the silence around it. This is the true end of the stellar legacy, not the death of the last star, which was loud and warm and almost tender. Not the dissolution of matter itself, which was slow, almost bureaucratic. No. The real end is here. When the final black hole, the last concentrated object in the cosmos, surrenders the last packet of warmth, notice what is missing. There is no temperature in the ordinary sense.
Temperature requires particles bumping into particles, exchanging energy, reaching equilibrium. That can no longer happen. The cosmos is too dilute. Two particles, if we can still speak of such things, are separated by unimaginable gulfs. They cannot meet. They cannot share heat. They cannot even, in any meaningful sense, exist in the same universe anymore. There is also no shape. A shape is a relationship between parts. It requires parts to have near neighbors. But expansion has sundered every object from every other object. Anything that tried to be a thing would be torn outward by the quiet, ruthless growth of space itself. Even the gentlest bond between particles is now weaker than the relentless stretch of the vacuum. In this era, the universe is not a place.
It is a direction, and that direction is a part. Think about what that means for the old idea of a cosmos. A cosmos, in the Greek root of the word, was an ordered whole, a thing with parts that fit together, a place where things could meet and collide and combine. That word no longer applies. There is no meeting. There is no fitting. There is only the patient, universal withdrawal of every particle from every other particle until the very concept of together has no more work to do. Something strange happens to your intuitions here. You want to imagine an observer floating through this cold expanse, watching the last photon recede into the distance. But there is no observer. There is no distance.
There is no such thing as watching. The very conditions that allow the word event to have meaning have been politely dissolved. And yet, for a moment, let us break the rules. Let us pretend that someone is present, a witness, a single awareness allowed by some trick of story to hover above the dying black hole and watch. What would they see? A pinprick of radiation, winking out. A slight ripple in the geometry of space, a barely detectable tremor, and then nothing. They would wait. They would keep waiting. They would never see another event for as long as they stayed. They would, in time, forget what events were. They would become, perhaps, a part of the stillness themselves. And still, something lingers. Not matter, not light.
Not memory, only the fact that it once was. The cosmos has nothing left to do except remain. The last radiation carries information that will never have a reader.
This is where our story should end, and for a long, long while it does. The universe has reached the condition physicists called, in the 20th century of the human era, the heat death. The phrase is almost too warm for what it describes. Heat implies a hearth, a fire, a place that holds a temperature. Here there is no place, only a maximum of entropy, spread thin across a volume that never stops growing. Every particle that still exists drifts alone. The cosmic horizon has retreated so far that nothing can signal to anything else. Space expands faster than light can cross it, and so each particle, in its own small bubble of observable reality, is effectively the entire universe to itself, a single photon in an empty shell.
A single electron in a cage of light years piled upon light years. Temperature approaches but never quite touches, absolute zero. Movement approaches stillness. Change approaches silence. Let this settle into you. You have a body right now. It is full of motion. Atoms vibrating. Blood moving. A heart keeping its quiet rhythm. Every one of those motions is, at its root, a small thermal dance. Heat in the body of a creature is the same phenomenon as heat in the body of a star. It is particles bumping, jostling, exchanging energy. In the era of heat death, there are no such exchanges, no dance, no rhythm, no heartbeat of any kind. The universe has unlearned the grammar of warmth. Now ask yourself a question.
If nothing ever changes again, does time itself still exist? Time in physics is the direction in which entropy grows. But once entropy is maximized, that direction loses meaning. There is no past to compare against. There is no future that will look different. A second and a trillion years become indistinguishable, because neither is marked by any event. The universe has not stopped. It has forgotten how to count. Ask another question. If no consciousness is present, is there still a universe at all? We like to think the cosmos does not need a witness to exist, that it hums along whether we look or not. But here, in this era, the entire apparatus of observation has been dismantled. No eye, no detector.
No mathematician to assign coordinates to space. The cosmos has outlived its own language. Does something exist if there is no longer any possible statement about it? Physics has no answer. Philosophy has no answer. Only the silence itself does, and it is not telling. And yet, in this quiet forgetting, three strange possibilities flicker. The first is called Poincaré recurrence. It is an old theorem from an old mathematician, and it whispers something uncomfortable. In any closed system with finite possible states, given enough time, the system must eventually return to a configuration arbitrarily close to any previous one.
If the universe is truly finite in its accessible states,
then after a duration so vast that 10 to the 100th power years looks like nothing, the random dance of particles might, by pure chance, reassemble something that resembles structure. An atom might form a molecule. Perhaps, with enough patience, a star. Perhaps even a galaxy. Perhaps even a human mind. Imagine that. After the heat death, after eternity itself has grown old, a shape reappears. Not because it was willed, not because it was remembered, simply because, in an infinite ocean of noise, every wave must eventually repeat. But these recurrences, if they occur at all, are separated by timescales so monstrous that even writing them in scientific notation strains the language.
The recurrence time for a universe like ours is estimated at 10 to the power of 10 to the power of 120 years. A tower of exponents, a number that mocks the idea of number. Would it even count as rebirth? The matter would have no memory, no lineage, no connection to the cosmos that came before. Just a momentary flicker of order, rising out of chaos and sinking back into it, unwitnessed.
A dream that no dreamer will ever remember having. The second possibility is darker. It is called vacuum decay. The quantum vacuum, the ground state of empty space, may not be as stable as it looks. Some theories suggest it sits in a false minimum, a shallow dip above a deeper true minimum waiting below. If somewhere, by sheer quantum chance, a tiny bubble of true vacuum forms, it will expand outward at the speed of light, rewriting physics as it goes. Inside the bubble, the constants of nature change. Atoms cannot form. Light itself behaves differently. Everything the old cosmos contained is erased, not destroyed violently, but simply replaced, the way a chalkboard is wiped clean for a new.
And because the bubble moves at light speed, nothing can ever see it coming. It arrives as the silence at the end of a sentence. In the heat-death era, there is no matter left to erase. But the bubble would still sweep through, announcing with perfect patience that even the stillness was temporary, that even the final rest was provisional, that the universe, having surrendered everything, could still be asked to surrender one more layer. We do not know if this will happen. We do not know if our vacuum is the true one or only a pleasant mistake. But somewhere out there, beyond the reach of any observer, the dice are still rolling. The third possibility is perhaps the strangest of all. It has a name like a fairy tale. Boltzmann brain. In an eternal universe of thermal fluctuation, every possible arrangement of particles must eventually occur, and that includes arrangements that briefly form a conscious observer. Not a body, not a planet,
Not a life in any sense we would recognize, just a configuration of matter, held together for a single moment, that has the same pattern as a thinking mind. It would open its eyes in a universe of near total emptiness. It would have for an instant a sense of self, memories perhaps, feelings, a name. Then it would dissolve, its particles returning to the long quiet, leaving behind nothing but the faintest ripple of entropy. Statistically, such flickers of consciousness may outnumber every real observer who ever lived.
More Boltzmann brains, across the infinite reaches of time, than beings who were born, raised, and loved into being. An ocean of brief, accidental awakenings, scattered through an emptiness that is otherwise absolute. Try for a moment to imagine being one of them. You come into being with a history that never happened. You remember a childhood that was never lived. You feel the warmth of a sun that never warmed anything. And then, before you can even finish the thought, your particles return to the noise from which they came. Was your moment of awareness real? By every physical measure, yes. You had a structure. You had a thought. You had a fleeting inner life. It was just extremely brief and extremely alone.
If you find that thought unsettling, sit with it. Let it settle like snow. It is not a horror story. It is only a consequence of very large numbers meeting very patient physics. There is a deeper puzzle hiding inside this one. If Boltzmann brains are more common across all of time than real observers, then on purely statistical grounds, any given conscious moment is more likely to belong to such a brain than to a being with a real history. Which means that this moment, right now, the thought you are having as these words settle into your mind, might itself be a brief thermal accident in a cosmos much older than you realize. There is no way to tell. The mathematics does not distinguish.
Most physicists consider this a sign that something is missing from the theory, rather than a real conclusion. But the puzzle remains politely refusing to resolve itself, hovering at the edge of the science like a quiet ghost. So which is the true ending? The quiet stillness of maximum entropy, the unreadable whisper of Poincaré recurrence, the clean sweep of vacuum decay, the fleeting dream of a Boltzmann brain. Perhaps all of them. Perhaps none of them. Perhaps the universe does not choose. Perhaps it simply allows every possibility to happen once somewhere, in silence. Let the numbers fall away for a moment. Let the diagrams fade. Close your eyes and try to feel what this means. Not as a lesson, not as a warning, just as a fact.
Every star that ever shone, every planet that ever turned beneath a sun, every ocean that ever held a sky, every creature that ever paused to wonder why it was alive, all of them were brief, all of them were held together, for a little while, by the tension between light and gravity, heat and cold, matter and void. That tension was the story. The story was the warmth. The warmth was the gift. And when the warmth is gone, the universe does not mourn. It does not celebrate. It does not remember. It simply settles. There is a kind of peace in that. A peace deeper than any sleep you have ever known.
It is the peace of something that has finally, completely finished moving. A stillness so total that even the word stillness feels too loud to describe it. And yet, this peace is also a kind of generosity. The cosmos does not resist its ending. It does not cling. It does not try to preserve a single grain of itself against the long cold. It simply lets go with a patience that no creature has ever matched. In that letting go, there is a lesson the universe has been quietly preparing across every one of its ages for anyone who still has ears to hear. You will not be here for this. Neither will I. Neither will anything that has ever loved or questioned or hoped.
The cosmos that does the remembering will be long gone before the cosmos that does the forgetting arrives, and maybe that is the point of stories like this one. We are telling ourselves in advance about a stillness we will not witness. We are practicing the silence while the warmth is still here. Breathe in, breathe out. The stars are still shining somewhere above you tonight, burning down their fuel, patient as lanterns. They do not know that this ending is coming. And it is coming. But not soon. Not for you. Not for anyone whose name you will ever learn. There is time. There is still an enormous amount of time.
Enough for many more dawns, and many more stories, and many more quiet thoughts on many more quiet nights. The universe did not begin with a promise. It began with a flash. Light and matter, hurled outward from a condition we still do not fully understand, given just enough structure to assemble stars, and from stars, worlds, and from worlds, us. For a span of time so tiny, within the full arc of cosmic history that it barely registers, there was warmth, there was motion, there was someone to notice. And then, in the slowest motion imaginable, the warmth thinned, the motion eased, the noticing dissolved. The universe does not end with a bang. It does not end with a whimper. It ends with a quiet understanding.
That it no longer remembers why it began. Act 3 end. Total words 4W980 core.